All right, what is up, everybody? Let's get into Unit 8.6. So this is when we're going to start using some trig functions for non-right triangles. All right, so notice the way I laid out the diagram here in this triangle. Notice how I have capital letters for the vertices and lowercase letters for the sides. And notice that the letters are opposite. They're same, or they're upper or they're lowercase, depending on how you want to look at it, right? So capital A is opposite lowercase a, and capital B is opposite lowercase b, etc. Now, the reason that we do this is because when we use the law of sines, the ratios we're going to be creating involve an angle and a side. Remember, so a ratio is a fraction, and the angle and the side are always opposite each other in the ratio that we make. So that would be a ratio that I'm talking about, right? So like the sine of A over A. And so the law of sines is actually pretty easy in that ratio, sine of A over A, is going to be equal to every other ratio like it, meaning every ratio that is the angle over the side length. So the sine of B over B, the sine of C over C. Now, I usually put the angles in the numerator. If you wanted to flip this and make it like A over the sine of A, B over the sine of B, you totally could, as long as you stay consistent with your setup. All right? But that literally is the law of sines. And so we use this when we have a complete ratio and then maybe one side length or one angle of another piece of our triangle. All right, but the way that we know to use law of sines is, number one, it's not a right triangle. Number two, I have a complete ratio. Like, I know what this angle measure is, and I know what this side length is. From there, then, we really only need like one or two pieces of information to find something that's missing. Okay? So if I'm looking at this triangle right here, okay, can you find the complete opposite ratio, meaning you know the angle and you know the side that's opposite that angle? Hopefully your eyes fell on the 80-degree and the side length 3. So for us, that first complete ratio would be the sine of 80 over 3. Our other two ratios would be sine 45 over b, and then we can use our calculator to find the measure of angle A, because all three angles have to add to 180. So 180 minus 80 minus 45, that missing angle is 55 degrees. So our other ratio would be the sine of 55 over A. And so once we have all three ratios set up like this, if we're asked to solve the triangle, I believe in the homework you're just finding a missing side or a missing angle, we can use just how we did in our past. This is kind of like our scale factor. We use that complete ratio to solve for all the other stuff. So I know that the sine of the sine of 80 over 3 is going to be equal to the sine of 45 over b. And I would make another equation using that sine of 80 over 3, and I would make it equal to the sine of 55 over a. And so the key thing is, guys, for the problems like this, is just putting the ratios together correctly. And then from that point, it's going to be using your calculator. All right, so what I'm going to do is I don't want to use my calculator until that variable is all by itself. Okay, so we're going to cross multiply. When I cross multiply, I get b times the sine of 80 equals 3 times the sine of 45. Then I want to get b by itself, so I'm going to divide by the sine of 80. Divide by the sine of 80. So that means that b equals 3 times the sine of 45 divided by the sine of 80. And this is what we want to put in our calculator right here. And so I'll see if I can make a video showing you exactly how to do this with the online one, because there might be a little bit of a trick. You can use something called the previous answer. But what's nice about scientific calculators is usually if I do 3 times sine 45 and then don't clear it, and then I press the divide button, it will take the previous answer that I just got and divide it by sine 80. So like 3 times sine 45, whatever you get there, don't press anything, don't press clear, then divide that, so you just press the divide button, and then enter in sine 80, and then hit enter. Okay, so 3 times sine 45, that gets me 2.12. Okay, so I'm not going to round that. So this is good practice. Like, we don't want to round 2.12 because see all those numbers that we would cut off, 2.12132034356. Instead, if you just press the divide button, you should see ANS. So it says ANS, and then it has the division symbol. ANS is referring to the previous answer that was calculated in your that was found in your calculator. So that 2.12, that's what ANS is. And I can just press divide that by sine 80. I get B equals 2.15, or 2.2. Okay, so again, you would just do 3 times the sine of 45. Whatever you get there, just hit the division button, and then it should pop up on your calculator, ANS divided by sine of 80, hit enter, get 2.15, or 2.2. Okay, let's look at our problem for A. Cross multiply A times the sine of 80 equals 3 times the sine of 55. I'm going to have to divide both sides by sine 80. So then A equals 3 times the sine of 55 divided by, sorry about my writing there, the sine of 80. And you do the same process. 3 times sine 55, you get 2.4574 divided by, so now I should say ANS division symbol, sine 80. And we get 2.5. So A equals 2.5. Okay. Let's do another problem. Okay, so just so we're all aware, this is 9, and this is the letter A right here. Okay, so where's our complete ratio? Our complete ratio is with the 53 and the 9. So the sine of 53 over 9, and then let's go ahead and find the measure of angle A, 180 minus 100 minus 53. That gets us an angle measure of 27. So then the sine of 27 over A, there's our first equation, and let's make our other one. The sine of 53 over 9 equals the sine of 100 over C. Let's go ahead and do our cross multiplying. So A times sine 53 equals 9 times the sine of 27. Divide by sine 53. So A equals 9 times the sine of 27 divided by the sine of 53. 9 times the sine of 27 gets me 4.0859 divided by, so ANS, sine of 53 gets me 5.1. So our value for A is 5.1. Alright. Next one, cross multiply it up. Let's do this one a little bit faster. So C times the sine of 53 equals 9 times the sine of 100. I have to divide by sine 53, so I know C equals 9 times the sine of 100 divided by the sine of 53. 9 times sine 100 gets me 8.863269 divided by the sine of 53 gets me 11.1. And guys, remember, the way we can check this is the largest side should be opposite the biggest angle, and the shortest side should be opposite the smallest angle. And so notice that C is opposite the 100, which is our largest angle. A is opposite 27, which is our smallest angle. And C is 11.1, A is 5.1. We're good to go for the most part. So these past two problems, we've been solving for missing sides, okay? There is a little more calculator work, right, if we need to solve for a missing angle. So I'm going to skip this one for right now, and we're going to do this problem here. And so we're just solving for angle X. All right, the setup is still the same. So I'm still going to do opposite ratio, the sine of 86 over 26, but now it's the sine of X over 18. Okay, and so this is where it gets a little bit more complicated in regards to the calculator work. So I'm still going to do my cross multiplying, so I'm going to get 18 times the sine of 86 equals 26 times the sine of X. I then would need to get the sine of X by itself, because remember, sine of X means we're going to be doing an inverse. Okay, so I'm going to, just like when we did inverse in right triangle trig, so I'm going to divide both sides by 26. So that means the sine of X equals 18 times the sine of 86 divided by 26. And so here's how you want to enter this in your calculator. All right, follow this step by step. We're going to do 18 times the sine of 86. That gets us 17.956. We're not going to clear that value. We're now going to divide by 26. That gets us 0.690621. So we need to take the inverse value of that decimal. Now, the easiest way to do this is just round that decimal to like 4 places, so like 0.690621. So right now, guys, on my calculator, this is what I'm looking at. Sine of X equals 0.690621265565. That's everything that's on my calculator. Now you could, like I said, take the inverse sine of like the first 4 and you'll get the right answer. Okay? But the other thing that we have the capability to do is we can actually manually access the ANS feature. Okay? So what I'm going to do now is I'm going to go inverse sine. So I have to hit my second button, and now I should say sine to the -1 on my calculator. Then I'm going to hit second, and in the bottom right-hand corner, you should see an ANS. Literally, it says ANS. That's manually accessing the previous calculation. Our previous calculation, or answer, was this guy right here. So when I do that, now on my calculator, it says sine to -1, ANS. Now, you can't just type in the letters A, then N, then S. It has to be actually accessing the ANS function. Okay, so what this is doing is taking the inverse sine when it says ANS of this entire number without me having to type the whole thing out. Okay, and I hit enter, I get 43.8. So that missing angle is 43.8 degrees. And once I have that angle, I could then find angle C by doing 180 minus the other 2. And once I know angle C, I can use the law of sines, again, to find the length of AB. All right? Let's do one more like that. Okay? And then that'll wrap this video up. And then I'll make a video using the calculator as well, guys. Okay? So, looking at this, so we're trying to find the measure of angle A, because that's opposite the 10. We don't know what that is. We'll call it Y. We have our complete ratio of 95 and 24. So the sine of 95 over 24 equals the sine of Y over 10. Let's go ahead and do all of our cross multiplying. So 24 sine Y equals 10 sine 95. Divide both sides by 24. Sine Y equals 10 times the sine of 95 divided by 24. Once that sine Y is by itself, we're going to take the inverse sine of that amount. So 10 times the sine of 95 gets 9.96 and a bunch of other numbers divided by 24. So what I'm looking at right now on my calculator, After I did 10 times the sine of 95 divided by 24, I'm looking at 0.4150811242205. Okay? And again, you could just round that to like 0.4151, and you get a pretty close answer to what I'm about to do, but the correct way is to use the ANS function. I'm going to press shift and then I get my sine button, so I have sine of -1, and then I'm going to press shift again, so I get my ANS, and I get 24.5. So my missing angle measure is 24.5. And again, guys, once I know this is 24.5, I can find this angle here, and once I know angle C, I can use law of sines again to find the length of BA. I'm going to make a video using the calculator just to show you what I mean by the ANS feature. All right?